Hello and good afternoon, everyone. I'm Ishmael Tyler, and I worked under Sarah Zhang in Professor Andy Thompson group exploring Antarctic sea ice trends. Starting off with what Antarctic sea ice is. Antarctic sea ice is frozen, floating ocean water that floats on the surface of the sea. It differs from icebergs, which originate on land. Antarctic sea ice is unique as it is seasonal and most of it melts in the summertime. You can see this change in this image over here. On the left, you see February, which is in the summertime, and you can see that sea ice extent is very low. And then on the right, you can see in September, the winter, and you can see that sea ice extent is at its peak. Sea ice is important as it plays a key role in cooling the planet, acting as a giant reflector for sunlight. In addition, it affects ocean circulation when it melts. Wildlife also rely on sea ice as it determines their territory and distance to feeding grounds. This graph shows trends in sea ice extent. Sea ice extent measures regions with at least 50% sea ice coverage. This graph measures sea ice extent in millions of kilometers squared, and this graph got its data from satellites. As you can see, before 2017, there was an increasing trend in the overall amount of sea ice, and many years had above the expected average of sea ice. However, since 2017, that trend has been flipped, and many years have had less sea ice than expected. The goal of this project was to measure and analyze Antarctic sea ice changes in the past 30 years. This was done using ECHO modeling. ECHO, which stands for Estimating the Circulation and Climate of the Ocean, utilizes ocean circulation models with data systems to get a complete model of the ocean systems. I used version 4 release 5 for this project, which goes from 1992 to 2024. In addition, I also learned basic Python to be able to take ECHO's data and plot it into something usable. This first graph shows mean annual sea ice extent again being regions with at least 50% sea ice coverage. This graph measures sea ice extent in millions of kilometers square on the y-axis, and on the x-axis you have the year. It can be seen that there has been overall an increasing trend in sea ice extent, with a few anomalies in 2017 and in 2023 that stand out. This graph is similar to the previous, except it divides sea ice extent by season. When sea ice extent is, as we expect, sea ice extent is greatest in the winter and fall, and lowest in the spring and summer. September is known for having the greatest amount of sea ice, and March is known for having the least. This graph shows sea ice extent anomaly over time. The blue line is sea ice anomaly measured in millions of kilometers squared. The red line is the zero line, and the black line is the trend line. This differs from the first graph, as the first graph was observed satellite observations. However, this is based on ECHO modeling. It's a good thing they're similar though, as it shows ECHO is fairly reliable. Based on the black line, we can see that in the past 30 years, there has been an increasing trend in sea ice. However, recently there has been an increasing number of negative anomalies. If we were to remove the past 10 years from our data set, we'd get a steeper positive trend line. But if we were to focus on just the past 10 years, we'd get a slight negative one. As well as measuring sea ice extent, you can also measure sea ice thickness. This graph measures circumpolar, which means across the entirety of the Antarctic, mean sea ice thickness in meters. The peaks are in the winter and fall months, and the dips are in the summer months. The small peaks that you can see before the big peaks are caused by residual sea ice left over from previous years. It increases the mean until new sea ice can form. This graph shows sea ice thickness anomaly. Trends in sea ice thickness tend to be more nuanced than trends in sea ice extent, and it's harder to find an obvious trend. Another thing to point out is the dip in sea ice thickness in 2023, which correlates to a dip in sea ice overall extent as well. To get an actual total amount of sea ice, we have to calculate sea ice volume. Sea ice volume is calculated by multiplying sea ice thickness by total sea ice area. This graph measures sea ice volume in millions of kilometers cubed. Once again, the peaks are in the summer. The peaks are in the winter and fall months, and the dips are in the summer months. For this slide, I decided to compare sea ice volume anomaly on the top to sea ice extent anomaly on the bottom. As you can see, they are very similar, however, they are not identical, which shows us that sea ice thickness does still play a role in overall sea ice volume. However, quantitatively, sea ice the extent plays more of a role in sea ice volume than thickness. In conclusion, there has been a changing trend in sea ice these past few years. This is supported by Raphael et al., whose team determined that these changes were unlikely to be due to chance and suggested that Antarctica might be undergoing a structural change. In addition, quantitatively, extent plays more of a role in sea ice volume than does sea ice thickness. Personally, I wanted to learn something new from this project, and I have. I learned a lot of new abbreviations as well as sea ice, obviously, and I also learned at least some of Iceland. In the future, one could map sea ice thickness, volume, and extent regionally. All of my data was taken across the entirety of the Antarctic. However, if you wanted to compare different regions to each other, you could. Here are some of the sources I used, and I'd like to thank the Summer Research Connection for giving me this opportunity, Sarah Zhang and Professor Andy Thompson for helping me along the way, as well as you all for listening. Thank you.
Have any questions for your stuff?
Yeah.
I have a question. You described the small bumps and maybe the large bumps.
Yeah.
The ice thickness. Can you just explain that a little bit more?
Yeah. Let me connect it up so I can point to it.
Sorry.
I just didn't want to move away from the mic.
Yeah.
So I'm not tall enough, but you have the big peaks and then like kind of in the middle, there's like a small hump and basically not all the sea ice melts. Thank you. This peak and basically not all of the sea ice melts. So when taking an average over the entirety of Antarctica, it also takes that into consideration. And because not all the rest of the sea ice has formed yet, there's a bump, but once the rest of the sea ice forms, the entire thickness catches up with that. Oh, yeah.
Did you have Python skills coming into this?
No.
You started from scratch?
Yeah.
What you need, that's started by doing, that's great. Is this something you think you might be interested in pursuing now that you've had a summer doing this particular research? Do you think this is a general path you might want to go toward?
Maybe, I don't know for sure.
Yeah.
Yeah.
You've got time.